Patterning in algebra. A pattern. A pattern is a group of numbers, shapes, or objects that follows a rule while repeating or changing. So if you have a number and you're trying to find the pattern, you see how the number skips or changes as it goes through. So it could be any pattern. We'll do a simple one just to get you going. So if you have the pattern 1, 2, 3, 4, 5. In this pattern, the number changes. It increases by 1 each time. So as the number goes on, it increases again and again by 1. You're simply adding 1 to the previous number to make the pattern. Okay? So this is a simple number pattern. You can have more complicated number patterns, and we'll get to different patterns as we go through it. So the next thing is a term number. A number that tells you the position of an item in the pattern. So you know how we had the previous pattern. Let's go back to it. And again, it was a super simple pattern. The pattern, well, let's change the pattern a little. Let's say the pattern is now 3, 4, 5, 6, and 7. And again, the pattern still only increases by adding 1. And again, we're increasing the pattern as we go through. So this is our pattern. That's our pattern. That is how our pattern is increasing as it goes through. The term number is where the pattern is. Okay, so here's our term number. And the term numbers would be 1, 2, 3, 4, and it's the position of the number in the pattern. And again, 3 is our first term number, 4 is our second term number, 5 is our third term number, and 6 is our fourth term number. We can keep going, but we kind of ran out of space there, and that is known as our term. So that's our term. The next thing we're going to talk about is our variable. And a variable is a letter or symbol that is used to show a quantity. And again, you can use any letter. A variable means it is an unknown number. So you can use X, you can use N, you can use anything you want, basically, to show a variable. Now the variable comes in algebra when we're talking about the nth term. And so when we're talking here about the term number, when we don't know what the term number is, so let's say we're looking for the 100th term, so we'd call it the nth term. We're looking for the nth term. This is our unknown term number. So we might be looking for what term would it be when we have an nth term. Okay, and this will become more clear as we do the couple of examples as we go through them. So let's look at our first. So our first example, I've given you a pattern. The pattern I've given you is 8, 12, 16, and 20. So when you have a pattern like this, the first thing you do is you set up yourself with a table like I did. So you have your term number, which is your nth term. Remember, if we're looking for an nth term, it would be in our term number. Then you have your term values, which are these numbers right here. And then you have a pattern, which we're going to find out what the pattern is. So the first thing I would do is I would go ahead and I'd take my term values and put them into my chart here. And so my term values are 8, 12, 16, and 20. And then I'm going to go ahead and put in my term number. So the 8 is the first term number, 12 is my second term number, 16 is my third term number, and 20 is my fourth term number. Now these can keep going, and again the pattern would keep increasing. So I could have a fifth term number and the pattern would increase, but I don't know what the pattern increases by right now. So that's what I'm going to find out. So I go ahead and I look at my pattern. So I say it goes from 8 to 12. So what's the increase? So I say, okay, let me try to add. If I add a certain number to 8, can I end up with 12? So I say, yeah, I can. If I add 4 to the number 8, it turns into 12. So I say, okay, now let me try that again. So if I add 4 to 12, will it end up with 16? So I say, okay, 12, 13, 14, 15, 16. Yes, it does. It works again. So I say I have to add 4. Let's try the next one. If I add 4 to 16, am I going to end up with 20? I go again, 16, 17, 18, 19, 20. Wow, okay, so my pattern works. I know that my pattern is increasing by 4. So if we're looking for, let's say, my nth term, so we're not going to label this 5. We're going to say this is going to become my nth term, my unknown. So I know. So now instead of saying we're going to be adding 4 as we go through a pattern, we're going to say, a better way of saying adding 4 would be to say we're going to multiply. We're going to multiply it by 4. So we're going to take our nth term and we're going to multiply it by 4. So I say, okay, let me try this now. Let's see if this actually works. So I'm just going to move my paper over a little bit. So let's see if this works. I say when the value of n, this is my n, when the value of n is 1, do I end up with 8 if I follow this rule right here? So let's try it. It's always worth a try. So I say when my value of n is 1 times 4, do I end up with 8? No, I end up with 4. So something is missing. Okay, so what do I need to do to this 4 to make it a value of 8? I know that if I add 4 more to it, it's going to give me a value of 8. So I'm going to say I'm going to add 4. Now let's see if we do this to our equation here, if it helps us out in solving the rest of the equation. So I say, okay, I'm going to now add 4 to this equation. I'm going to see if this works for me. So now let's try it again with the second term and see if we end up with 12 if we use our new formula here, or a new equation that we came up with, our algebraic expression. So I say, okay, I'm going to say when n equals 2. So let's try when n equals 2. So when my nth term is 2, am I going to end up with 12? So when n is 2 times 4 plus 12. So remember BEDMAS, we solve the multiplication first. So we go 4 times 2 is 8 plus 4. So then 8 plus 4 would equal 12. So it worked. But this is not a guarantee. So let's try another one just in case we haven't done this right. Okay? So we're going to try another one. So we're going to do another check to make sure we've done this right. So let's say when n equals 4, do I get 20? So let's try that. So now again, with my expression, I'm going to say, so when my n is 4, so 4 times 4 plus 4. Okay? So 4 times 4 is 16 plus 4. And again, I followed BEDMAS. I did my multiplication first before I did my addition. So now we go 16 plus 4 equals 20. So there we go. I know my expression works. So this would be my expression to solve for my nth term. Now the only thing we're going to make a correction here is we wouldn't normally write our expression like this. And I know that I've gone through this before. We would write our expression, because we don't write n times 4. We would rather write 4n plus 4. So we're just going to switch that around so that it makes a little bit more of a visual sense. So we would write 4n plus 4. So that is our expression for the nth term. Now the nth term could be anything. So I can say when my nth term is, and now let's say when my nth term is 100. When n equals 100, what is this value going to be? And so all I have to do is use the expression that I've come up with. And so if I plug in 100 into my nth term right here, so if I plug in 100 here, it would be 4 times 100, which would be 400, plus 4, which would be 404. So in my 100th term, this number would then be 404. Now let's do another example. This time I kind of want you to work with me, so I haven't drawn anything right now, and I want you to draw everything with me as we go through this question. So the first thing you're going to do is you're going to go ahead, and like I've shown you before, you're going to draw the chart, and this is your term number. This is your term, and then our last one is our pattern and what we see. So again, if you were to put these numbers into its place, this would be 1, 3, 5, 7, 9. And again, if I was to label them as my term numbers, 1 is my first term number, 2 would be term number 3, my term number 3 would be term 5, my term number 4 would be 7, my term number, 5 would be 9. So then I go ahead and I say, now let me try to solve this and see what the pattern is. So I come here and I say pattern. It's increasing by, what is it increasing by? So from going from 1 to 3, it is increasing by a value of 2. I simply had to add 2. So 1 plus 2 is 3. 3 plus 2, would that work? The same pattern? 3, 4, 5, yes it does. So it's increasing by 2. So then I go, okay, 5 to 7. Does that increase by 2? 5, 6, 7, yes it does. Now 7 to 9, does it increase if I add 2? 7, 8, 9, yes it does. So like I said before, remember if it's all adding going down, an easier way to add it is to just say that we are going to do a multiplication of your nth term. So if this is my nth term, it would be 2 times n, or n times 2. And I say, now let me see if this works. And I go ahead and I try it. So I say if my term, and again, I'm just going to move this up a little. If my term number is 1, and I put in my 1 here, so I say 1 times 2, is it going to equal a 1? So I try it out. So 1 times 2 equals 2. It didn't equal quite that. So what do I need to do to this number to make it equal 1? So I want it to equal a 1, but I got a 2. What do I need to do to this number to make it equal a 1? I go back to my math and I say, what mathematical concept can I use to reduce this 2 from a 2 to a 1? And I know that the concept I can use is a subtraction. So I can subtract, and I can subtract 1. When I subtract 1 from it, now I end up with the value of 1. So that means my formula here, my equation, needs to change from n multiplied by 2 to n multiplied by 2 subtract 1. This now becomes my equation. So I say, now let me do a check. Let me see if this equation is going to work every time that I do this. Okay, so I'm going to go ahead and I'm going to try it. Like always, I try it with one of my nth terms to see if it works. Just move that up a little. Let's see if I can erase this out here. No, well, let me erase it. Okay, so we're just going to kind of work on the side. Just ignore that right there. So I say, let's try the term value. Here we see 4 and the 7. So I say when my n equals 4, will my term value equal 7? So let's try it. So 4 times 2 minus 1. So 4 times 2 is 8. 8 minus 1 is what I'm left with. 8 minus 1 is 7. So it actually did work. If you look here, just right there, we see that my term value was 7 when my term number was 4, and that's exactly what I got here. So I know that my formula works. You can try it again with another one of them. So you can try 5 and 9 and see if you end up with the term number being 5, if your value ends up being 9. And you can see if your equation works. But this is the equation that you'd come up with. And again, this would be for any number to the nth term. And you can try any number and you'll still end up with the same answer that you're looking for. Now let's try another one. So now this time again, my example is different, and I've given you again a pattern, 6, 9, 12, and 15. And so the first thing you are going to do again is put your term number in place, your term value, and your pattern. So if I have 1, 2, 3, 4, this time I've only given you 4 values. I'm going to go a little bit smaller so I have more space to write here. And then my values are 6, 9, 12, and 15. And I say, what is my pattern? So I'm looking for the pattern here and seeing what my pattern is increasing by. So I look at my numbers and I say, okay, it's going up, and so we're looking from a 6 to a 9. How is this pattern increasing? So 6 to 9, can I multiply? Can I add? What can I do? So I say I can add. I'll add a 3. 6 plus 3 is 9. 9 plus 3 is 12. 12 plus 3, so 12, 13, 14, 15. Yes, that works. So I know that my pattern is increasing by 3. So again, we say, okay, I know my pattern is increasing by 3. Now, let's see if we can do this with the way that we've done the other one. So we say, now I'm going to end up with n times 3, just like we did before, and see if it works. So I say, now if I put my nth term in of 1, so if I take my 1 from here and I put my nth term in, so I put a 1 here, 1 times 3 is going to end up with 3, not 6. So I said, in this case I need to add 3 more in order to make it a 6. Will that be the same case for all the other ones? So let's try another one. Say it didn't quite work, so I know I need to add a 3. So I say, okay, let's put the term number in 2 here. So 2 times 3 is 6, 6, and then what do I need to add? I need to add another 3 to make it a 9. So I'm realizing that each time I'm adding a 3. So I notice that I'm adding a 3 each time, so I'm going to change my expression to add a 3. So now my expression looks like 3n plus 3. Now, like I've said before, you always want to test out your expression and see if it works, to make sure that the expression works. So now, when n equals, let's do when n equals 3. When n equals 3, will my expression work? So I do 3, I put in my 3, I put in my nth term, so I took my nth term from here and I put it into the expression, because it was 3n. And I go ahead and I do the math. 3 times 3 is 9. 9 plus 3, 9, 10, 11, 12 is 12. Is that the same answer here? So does the 12, is that the same thing we get here? And yes, it is. And again, you can try it again for 4 to see if you get 15. And you know that you've come up with an expression, that actually works. And this means that this expression would work for any nth term. So again, like I said, if we were solving for, let's say, the 15th nth term, means that I'd say when n equals 15, and then you would be solving the same way. So you'd say, this is my expression that I have. I'd put in 15 as my nth term. And once I put in that 15, then I have 3 times 15, which is 45, plus 3, which turns out to be 45, 46, 47, and 48. And there you go. So again, you know that if this was the 15th term, so if this continued as the 15th term, so if there was a 15 here after it went down all the way, then you know that this term number, or term value, would be 48. And you can use this expression again and again. This doesn't mean this is the only expression. There's other ways of expressing the same expression. You might come up with a different way from what I got, but this is just a way of me showing you a simple way of doing it. So now let's look at another one. And so again, I've given you values 3, 9, 27, and 81. I know my writing is a little messy, guys, but just kind of ignore that. Again, the same thing. You start off with a table, and this is the best way to do this, to actually put the numbers down in a table and look for the pattern. So I have my term number, I have my values, or my term values, and then I have my pattern. And so again, I would put in my term numbers, 1, 2, 3, 4, and then I would go ahead and put in my values, which in this case are 3, 9, 27, and 81. And then I'm going to go again and look for my pattern. This one is not as simple as the other ones we've done, so let's take a look at it anyways. In this case, I go, okay, how do I get from 3 to 9? So 3, and we can try adding. So let's try adding. So I go, if I take 3, and I go ahead and add 3, that's going to give me not 9. 3 plus 3 is 6. So okay, can't do 3 plus 3. So what other math concept can I use? And I go, okay, how about 3 times 3? Would 3 times 3 give me 9? So I type my multiplication, I say, you know what? That actually works. So, sorry, I just got to go back to the pen. If I have 3 times 3, I get 9. So if I do 3 times 3 times 3, I get 27. So I go, okay, this pattern is working. Each time I multiply the number by itself, I end up getting the number I'm looking for. So again, I'm taking not exactly what we did on the last videos. I know the last videos, the last couple of questions we did were all addition ones. We ended up showing a pattern through addition. In this case, we ended up with a pattern with multiplication. So it is different. And if you look at it, I know some of you are looking and going, how did she end up continuing with all these threes? Well, if you look, the 3 in this row continues as it goes down. So all I did was these 3 are here. I added one more 3 to get to 27. I copied down what's in the previous line, and I multiplied it again by 3 to get to 81. So think in math, when we have multiplied by a number by itself, how do we show that? We can't just show it as, like in the previous one we did, a number multiplied by the nth term. So how do we show a number multiplied by itself a certain number of times? And you're thinking, you're going, how do I do this? Do you remember exponents and putting a number to an exponent? When you put a number to an exponent, you're multiplying it to itself. So in this case, we'd have 3 to the exponent of the nth term. So whatever my nth term is, when I multiply it to my nth term, I'm going to get the value that I'm looking for. So I'm going to go ahead and try to make sure that this actually works. So if I go to the first one, if I look at my first term value is 1, and we're saying that this is my nth term, right? So this is going to go into the position of the n. So I take my 3, and I go ahead and I go 3 to the power of 1. 3 to the power of 1 means 3 multiplied by itself 1 time. So we're not doing anything. So 3 to the power of 1 is 3. So I say, okay, let me try the next one. 3 to the power of 2, which means 3 times 3. 3 times 3 is 9. There you go. My nth term being 2. 2 equals 9. So I go, let me try the next one. Again, we're just making sure that what we've done makes sense. So if my nth term, let's say in this case we're doing 4. Let's see if we end up with 81. So I go 3 to the power of 4 means 3 times 3 times 3 times 3 4 times. And again, you can use that magical exponent button on your calculator to figure this out. You don't have to actually write out 3 times 3 times 3 times 3. And you end up with 81. So I know my expression works. So an expression can be as simple as this, or as complicated as, or as more structured as the other ones that we've done, where you have a number multiplied by an n or a variable, and then subtract something or add something, whatever it is, or it could be as simple as an exponent. The next 2 examples that I have are examples that I want you to try. So I want you to go ahead and I want you to try. So you're going to try this. I've given you a pattern. This is actually not that difficult a pattern, but I want you to try it. So you're going to pause the video, you're going to make the chart, and then you're going to come back and see me. So go ahead and pause. Okay, welcome back, and now let's try this. See if you got what we're going to get here. So again, you did this. You did a term number. You did the term value. And you did your pattern. So 1, 2, 3, 4, and in this case I gave you 5 numbers. So you wrote down 5. You wrote down 4, 5, 6, 7, and 8. And you said, now how does my pattern increase? And again, this one was one of the simpler ones. And if you looked at the pattern, all you did was from here to here, we added 1. So I saw that my pattern always increased by a value of 1. So like we done before, we said, let's take our n times 1. So I go, okay, I'm going to do n times 1. And I say, let's see if this actually works. If I use this as my pattern, is it going to work? So I put in my nth term. In this case, the nth term is 1. So I go 1. 1 times 1 is 1. So I have to do something. That didn't work, did it? So 1 times 1 is 1. I have to add how many more to make it work? I have to add 3 more, is what I realized. Because 1 times 1 is 1. In order to get a value of 4, I'm going to have to add 3 more. So I'm going to add 3 more. Now, I don't know if this pattern is going to work each time. I know it worked with the first one, but will it work with term 2, term 3, etc.? So we try it out. Always try it out. So when n equals, let's say when n equals 3, let's see if I end up with the value of 6 when I have the term number 3. So I go n times 3. Oops, sorry again, guys. If I have n as a value of 3, so I go 3 times 1 plus 3. So 3 times 1 is 3 plus 3 is, so 3, 4, 5, 6, and I end up with a value of 6. Is that correct? Yes, it is correct. And again, you can try it with the rest of them to make sure that this works. But again, you'll realize that this pattern works. And so again, when we have n times 1, it just means n plus 3. Remember, I've told you guys in the past that when we have a 1, we actually do not show it in algebra. It becomes invisible. So you have this invisible 1 that is here, but we cannot see it. So you just write your expression as n plus 3. Okay, so this is the last question that I'm giving you. I've given you a pattern of 3, 7, 11, 15, and 19. Again, I want you to pause the video. I want you to try the question, and then I want you to come back and see if you got it right. Okay, so go ahead and pause. So welcome back, and now this is hopefully what you've done. You've gone ahead and you've drawn in your table. So you have your term number, you have your term value, and then you have your pattern. So again, in this case, I gave you 1, 2, 3, 4, and 5 term numbers. They are 3, 7, 11, 15, and 19. And again, I'm going to go through them now and see what I can figure out as a pattern. So you've already done this. So this is just you making sure you've done it correctly. So from 3 to 7, how do we get there? So 3, let's say if I multiply, it'd be 3 times 2, and that equals 6. So that wouldn't be multiplication. So I said, let me try addition. 3, 4, 5, 6, 7. So I'm adding 4. Now let's see if that works again. So if I take 7 and add 4, so 7, 8, 9, 10, 11. Look, see, it's working. So we say, okay, my pattern is probably adding 4. I continue down and I make sure. So yes, if I add 4 to 11, I end up with 15. And if I add 4 to 15, I end up with 9. So I see it's a continuation of a 4. So if you go back to the other pages, like your notes, and you notice that when I have an adding of 4, I go in and I say my term number times 4 is going to be my expression. So I'm going to go ahead and try it like I always do to make sure that it's done correctly. So if I put in my 1 times 4, I end up with 4. Didn't quite work, did it? Because when my term number is 1, my value should be 3. I did a term number of 1, and my value ended up being 4. So in this case, again, you're asking yourself that math concept. What do I need to do to this 4 to make it a 3? So would I add, subtract, multiply, divide? And I would figure out that I need to subtract 1. So from my, in my expression here, I know I need to add a subtract 1 in order to get the expression correct. Because now 4 minus 1 equals 3, which is the number of term 1. The value would be 3. So I say, let me try this expression out. Now let's see if this expression works. So I know my expression now is 4n minus 1. So I'm going to try it when n equals, and let's say when n equals 3. So I know when n equals 3, my term value should be 11. So I'm going to try it out and see if it works. Okay? So I know it's going to be 4 times 3 minus 1. So 4 times 3 equals 12, and 12 minus 1 is still part of my expression or my equation. So then 12 minus 1 is 11. And if you look, 11 is the term, for the term number 3, the value is 11, and that's exactly what we got. So when n equals 3, my value is 11. And I know my expression works. You can try the expression again with 5 and 19 and see if you get it, and then you know that your expression is correct. So I hope that you reviewed this video. Make sure you understand all the concepts that we've learned, but this is how we end up doing algebra and finding the expression.